DeepSeek has released an AI model that costs about 3 cents to complete a benchmark test. A comparable test using one of Anthropic's most advanced models costs more than $3. That is not a small discount. It is a difference of more than 100 times. DeepSeek V4-Flash does not appear to be the smartest model in the world. It does not lead every benchmark, and it may not replace the most capable systems from OpenAI, Anthropic, or Google for the hardest tasks. But it may represent something more disruptive. DeepSeek is showing that useful artificial intelligence can become dramatically cheaper before the industry has finished spending hundreds of billions of dollars to make it more powerful. The central question is no longer only which company has the best model. It is how much intelligence a business can buy for $1. According to research firm Artificial Analysis, DeepSeek V4-Flash costs approximately 14 cents per million input tokens and 28 cents per million output tokens. Its average cost across the firm's benchmark tests was around 3 cents. Moonshot AI's Kimi K3 cost approximately 86 cents for the same evaluation. OpenAI's GPT-5 Sol cost around $1.86. Anthropic's Claude Fable 5 cost roughly $3.15. The exact prices can change, and benchmark costs do not perfectly represent every real application. But the difference is large enough to change how companies think about deploying AI. A model that is 100 times cheaper does not need to be equally capable at everything. It only needs to be capable enough for the task. Imagine a company using AI to classify support tickets, summarize customer conversations, extract information from documents, translate product descriptions, generate advertising variations, or review routine software code. A premium model may produce slightly better answers. But when the company processes hundreds of millions of requests, a small quality advantage can become difficult to justify if the operating cost is 50 or 100 times higher. This is the economic opening DeepSeek is targeting. V4-Flash contains approximately 284 billion total parameters, but it does not activate all of them for every word it generates. Instead, it uses a mixture of experts architecture. A traditional dense model uses most of its parameters during each step of a response. A mixture of experts model divides its network into specialized groups. A routing system selects only the most relevant groups for each token. DeepSeek V4-Flash activates around 13 billion parameters at a time. That means the model can store knowledge across a much larger network while using only a fraction of the total computation for each response. Imagine a hospital employing hundreds of specialists. Every patient does not need to meet every doctor. A routing system directs one patient to a cardiologist, another to a neurologist, and another to an orthopedic surgeon. The hospital contains broad expertise, but only a small group works on each case. This is how sparse models attempt to combine scale with efficiency. The architecture alone does not guarantee low prices. DeepSeek must also optimize memory use, networking, inference software, and the way requests are processed across hardware. But activating only 13 billion of 284 billion parameters helps explain how the company can offer a large model at prices closer to those of much smaller systems. V4-Flash also supports a context window of up to 1 million tokens. In theory, that allows it to process extremely long documents, large code repositories, extended conversations, or collections of reports in a single request. A million token context does not mean the model will understand every part perfectly. Long context performance depends on how information is arranged, retrieved, and used. But the combination of long context and low pricing creates an important opportunity. Companies may be able to feed far more internal data into each request without turning every interaction into an expensive event. This matters because many business AI systems do not fail because the model lacks intelligence. They fail because supplying enough context costs too much. An insurance company may need to provide policy documents, customer records, previous claims, legal rules, and internal procedures before a model can answer one question accurately. A software agent may need access to thousands of files before modifying a complex application. When input tokens are expensive, developers aggressively reduce context. They summarize documents, remove history, and build complicated retrieval systems that provide only small pieces of information. Cheaper input changes that calculation. It may become more practical to send the model a larger portion of the original material and allow it to find what matters. The result could be simpler applications and more capable agents. But price comparisons require caution. Artificial analysis gave V4-Flash a score of 50 on its intelligence index. That reportedly placed it near Google's Gemini 3.6 Flash, while slightly behind models including Meta's Muse Spark 1.1 and Zhipu's GLM-5.2. This means DeepSeek is not offering frontier-level performance at 1/100th of the cost. It is offering competitive mid to high-level performance at an unusually low price. That distinction matters. For a difficult scientific problem, an important legal document, a complex coding agent, or a high-risk business decision, paying more for a stronger model may still be rational. The cheapest answer has little value when it is wrong. But most AI usage does not require the strongest model available. A company might use an inexpensive model for 90% of routine requests, then send difficult cases to a premium system. This approach is often called model routing. The application first estimates the difficulty of a request. Simple tasks go to the cheapest model capable of completing them. Complex tasks go to a more expensive model. If routing works reliably, businesses can reduce costs without giving up access to frontier intelligence. DeepSeek V4-Flash makes this strategy more attractive because the gap between the cheap and premium tiers has become enormous. The AI market could begin to resemble air travel. Most passengers choose economy class because it completes the main task. A smaller group pays far more for additional comfort, flexibility, or service. Premium AI models may remain essential, but they may handle only the requests where their additional capability creates measurable value. This places pressure on companies such as OpenAI and Anthropic. Training advanced models is extremely expensive. Operating them requires data centers filled with costly accelerators, high-bandwidth memory, networking equipment, cooling systems, and electricity. These companies need strong revenue to finance the next generation. But as cheaper models improve, customers gain bargaining power. They can compare outputs, switch providers, use open-weight alternatives, or combine several models behind one interface. The model itself risks becoming a commodity. This does not mean every provider will be forced to charge the same price. Anthropic may justify premium pricing through stronger reliability, safety systems, coding performance, enterprise support, or advanced agent capabilities. OpenAI may compete through integrated products, distribution, developer tools, multimodal systems, and consumer adoption. Google can connect AI to search, productivity software, cloud services, and Android. The strongest companies will attempt to sell more than raw tokens. They will sell trusted platforms, tools, data connections, security, and complete workflows. DeepSeek's low pricing accelerates this transition. When intelligence becomes cheap, value moves to the systems built around it. A restaurant does not win because it buys the cheapest electricity. Electricity is essential, but every competitor can purchase it. AI may move in the same direction. The model becomes infrastructure. The competitive advantage comes from proprietary data, customer relationships, workflow design, distribution, and the ability to turn model outputs into useful actions. There is another reason DeepSeek's release matters. The official V4-Flash model weights have been published, allowing developers to inspect, modify, and deploy the system themselves under its stated license. An API customer rents access to a provider's model. The provider controls the service, pricing, updates, and usage policies. An open-weight model gives organizations more control. A company can run it on private infrastructure, fine-tune it for a specialized industry, examine its behavior, and avoid sending sensitive information to an external service. This can appeal to governments, banks, manufacturers, healthcare providers, and companies operating in countries where dependence on American cloud services creates political or regulatory concerns. However, open weights do not make deployment free. V4-Flash remains a very large model. Running it efficiently requires significant computing resources, specialized engineering, and enough memory to store its parameters. The API may be cheaper for most small organizations than operating the model themselves. Open access provides choice, not zero cost. DeepSeek also faces trust and geopolitical problems. Chinese AI systems have been criticized for restricting answers involving politically sensitive subjects. Companies outside China may worry about data handling, censorship, security, or future government restrictions. Governments may limit the use of Chinese models in sensitive systems. American officials and AI companies have also accused Chinese developers of using unauthorized distillation to learn from Western models. Chinese officials have rejected claims that the country's AI progress depends on copying American technology. These disputes will influence adoption. A model can be technically attractive while remaining unacceptable for certain customers. This creates a divided global market. Some businesses will prioritize maximum capability and trust established Western providers. Others will prioritize low-cost, open deployment and independence from American platforms. Many will use both. The most important effect of V4-Flash may therefore be indirect. Even companies that never use DeepSeek can benefit from the pressure it places on competitors. OpenAI, Anthropic, Google, Meta, Alibaba, Moonshot, and other developers must now improve not only intelligence but efficiency. Every laboratory must answer a harder question. Why should a customer pay 50 times more for this model? A vague claim that it is more advanced will not be enough. Providers will need to prove that a premium model completes tasks more accurately, uses fewer retries, requires less human review, or produces outcomes worth the additional cost. The relevant metric becomes cost per successful task, not cost per token. A cheap model that fails repeatedly may be more expensive than a premium model that succeeds immediately. A costly model that performs simple work only slightly better may be an unnecessary luxury. Businesses will measure the complete workflow. This is where the price war could become healthy for the industry. For several years, AI progress was presented mainly as a race toward larger models, more parameters, more chips, and larger data centers. DeepSeek is forcing attention toward efficiency. How many parameters must be active? How much memory is required? How many tokens can be generated per unit of electricity? How much does one correct answer cost? These questions determine whether AI remains an expensive tool used selectively or becomes infrastructure embedded in every product and business process. Ultra-cheap models could create enormous new demand. A company that cannot afford 1 million premium requests may be able to afford 100 million inexpensive ones. Developers may add AI to security cameras, industrial equipment, educational software, logistics systems, small businesses, and consumer devices. Lower prices do not necessarily reduce total industry revenue. They can expand the market. The history of computing repeatedly follows this pattern. Computers became smaller and cheaper, then appeared in offices, homes, pockets, vehicles, appliances, and factories. The cost of each unit fell while the total amount of computing consumed exploded. AI may be entering the same phase. The industry has spent years proving that machines can reason, generate, code, and analyze. The next competition is to make those capabilities cheap enough to use almost everywhere. DeepSeek V4-Flash does not settle the AI race. Stronger models still matter. Safety still matters. Reliability still matters. Access to advanced chips still matters. But it changes the question companies must answer. The winner may not be the laboratory that builds the single smartest model. It may be the company that makes intelligence inexpensive enough for the world to use without thinking about the cost.